without any further ado, I'm going to introduce Fatih, who's going to give his presentation on Hardware Hacking Chronicles, IoT Hacking for Offense and Defense. If you can all give him a round of applause.
Thank you. Is my voice clear for the last lines? Can you hear me? Hands up. All good. Yeah, my name is Fatih, and I'm working for Context. But today I will talk about hardware hacking, though I will talk about the devices. So if you are coming from a service provider or a sort of subscriber service presenter, do not be offended, because I will not talk about service providers. Most of the time I will talk about the devices and how we can alter them to attack the services background, which is backend services, infrastructure, or other devices. The second one is, I will show some photos and demos, and I will explain some attacks. First one is, all those devices are mine, my property. Some of them from my ex-contacts, and some of them from eBay and Gumtree, because I had plenty of times on Christmas, last Christmas, I was changing my job. So I had, let's say, 2 months vacation. It is a lot for a tech guy, so I just opened all the boxes. So you will see some pictures from my boxes. Moreover, if you are so keen to play with all those tools, probably you will need helpers. I will talk about them, but I have almost all of them here. Only missing ones are RF tools, SDR, and the other tools. But the rest are here. So if you are so keen to talk about it, please find me during lunch. And now, my name is Fatih Ozavci. I'm a fracker, so I had some unified communications experience, and of course, some network infrastructure and hardware hacking. I am also author of vPro and Voice over IP World Security Research program, so I have presented almost all the major events, except RSA. They don't like me, I don't know why. But the other tech events, including Black Hat Europe, USA, DEF CON, Hack in the Box, AusCERT, RacksCon, KiwiCon, Troopers, that's my favorite. Anyway, I was everywhere to talk about my favorite topics. But today I will talk about some additional topics, which are IoT and hardware hacking. And I will try to explain what are the subscriber services and how they use IoT. And I will explain my hardware hacking chronicles between that 2 months period. Moreover, actually, I was focusing on some additional services as well, but I will talk about only broadband devices and office devices here. So after that, I will also offer some solutions to the service providers and also penetration testing teams, because we need to improve some stuff. When we call Internet of Things, we see too many things, actually. And they are real things. Baby monitors, just real babies, Barbies, and etc. I don't know. Yes, we should pay more attention to them, but I don't care. Maybe we need a new terminology for them, because subscriber devices are also IoT devices. They are connected to the net infrastructure, or they are connected to a restricted network, which I will discuss later. And they provide some data from customer to service provider or vice versa. So they can be also under some security threats. And office devices, they are also vulnerable for some hardware hacking attacks, 3G, 4G modems, access points, IP phones, keyboard and mouse. So they are everywhere. So we can use hardware hacking skills to attack almost all of them. So the question is why we should evolve. And Internet of Things is changing, so we hear too many privacy violations regarding all of them. But who cares a baby? That's another topic. My focus is much more sensitive devices. Medical devices are also important, but this is, again, another talk. I will talk about broadband devices and some business devices. So I will focus on the business risk. Yes, consumers are under threat, but what about the business? What about the service providers? Because they get money through those services and they have some challenge with those devices. So we need to solve them. Some routers are under attack all the time, and this is not a news. Moreover, some of them also shipped with some official backdoors. So when you get a device from a service provider as a part of your contract, you may have a backdoor device, and everybody is fine with that. That is ridiculous. Moreover, some of the devices are well known. Cisco, Linksys, Netgear, they are all known. And some of service providers in Australia also offer those devices. However, in US, there are some regulations for them. And TP-Link, for example, will try to avoid customers to change its firmware. So basically, DDWRT or OpenWRT cannot be used on those devices in their perspective. This may be possible or not, but the discussion is there is a regulation for that, because customized software may manipulate the wireless signals, and that's why there are restrictions. And beyond of it, there are some privacy violations, and there are other regulations in that area. And of course, in Australia, there's a privacy commissioner, and he can visit any service provider to make things slightly serious. So those are the topics: broadband devices, IPTV devices, some of them are also satellite and broadcasting devices, and last ones are home and office equipment. So basically, we are getting those devices through service providers, and someone should take the responsibility, right? And let's talk about some of them. But before that, our traditional test approach is not sufficient. That is the first problem. And this is our problem. I am a security tester, a security researcher, and I know we are insufficient. We are insufficient because we are hired for a limited period. We do not combine additional skills because we are only resources for the Australian business. Most of the project managers use us as a resource. So project must start in a day and end in a day, and during the project timeline, we need to follow the budget. Result? Let's talk about it later. Can you make it? That is the major problem, and that's why all those devices are vulnerable here. And I will show some of them, and actually I will show the way. I will not expose any specific vulnerability targeting the service providers. But I will show the start path, and you can look more. Anyway, you'll see. But the traditional tests also do not cover the devices because they are not in scope. Most of the time, service providers get tabletop analysis for their design review, or they focus on some infrastructure services. That's why we get external network pen testing for a limited amount of IP addresses, let's say 100. But we are talking about service provider infrastructure. Those devices are at home, and they are getting managed in a protected network. And we need to follow the budget, so days are very limited. That's why we need to develop a new technology and new test methodology for all embedded devices. Therefore, we need to have a flexible one, because we may have multiple devices. We may have ARM or MIPS architecture. We may have Linux or VxWorks. We may have some old or new versions. So this must be very flexible. Also, this must focus on the device role, because a broadband modem can be a modem. If you want to buy one, there is an OfficeWorks or another IT shop, so you can buy one. But if you get one of them through the service provider shops, you will get a modem with some additional support from the service provider. That modem will have roles, for example, providing persistent unified communications features. Moreover, it will provide a video-on-demand service for you. So it is a part of business model. When you buy something yourself, you will get a modem. There will be no business. Maybe you may have concerns about your privacy, but I'm targeting the business here. So if we want to improve the business security, we need to focus on a methodology, because I will be not the only security researcher here, and I know we have too many good guys here, and they focus on iOS security and hardware security. So let's find out a methodology, and we can follow it, and we can improve, and we can share things. And device discovery is the first step. We need to understand the device. We need to understand the attack surfaces of this device, dumping the firmware of the device so we can work on that firmware to find vulnerabilities or maybe some additional attack surfaces and debug the network. And moreover, we need to fuzz it because some of the vendors do not pay attention to the software bugs. And lastly, we need to focus on the exploitation. And lastly, we need to improve our red teaming exercises. We need to work on the implants. And now I will talk about my days, my chronicles. So basically, what I do is so simple, and it is not hidden. It is not a kind of new discovery. Basically, I just downloaded modems interfaces, web management interfaces, and web management interfaces had limited functionalities. So what I did was downloading the configuration or backup. It has all the limited features. So you can edit a backup, and you can re-upload it back. What you can do is enabling secret interfaces, for example, Telnet or Secure Shell or something like that. You can harvest the credentials, such as unified communications credentials. Or you can easily extract some video-on-demand service licenses. They're all a part of this device, but you cannot reach through the web interfaces. You need to download the backup. The other one is much more interesting. They have secret handshakes. If you know the secret handshake, they enable the Telnet or Secure Shell interface with root access. Because it is used, there are public exploits for that. During my former engagements, I have developed one because the vendor explained this. If you put the device MAC address and hard-coded user and password, and if you calculate this with some additional values, you can send it to the Telnet interface. Even the Telnet interface is closed, it will be open without any password protection, and you will have root access. The other one is physical interfaces. And all this information available in the net, in forums, everywhere. As you can see, people talk about the credentials. I want to use a soft phone. I don't want to use the phone supplied by a service provider. How can I get the credentials from my modem? Sure, download the backup. Extract the credentials. Everybody knows this. I'm not exposing anything here. The other one is Telnet, Netgear Telnet console. It is not hidden. It is not secret. It is there. If you understand how can you do this, you can. If you don't, it is still fine. There are other ways. You can download the interface configuration. There will be a line like that, Telnet enabled. It is false. Make it true. And Telnet will be enabled. So you will have access to the device. Much more focused and complicated one, there are exploits for that. What they do is calculating the secret handshake again. And this one is another modem. So the Netgear and Sagem.com modems are important here because they are offered by Australian service providers here. And they are commonly used for NBN and ADSL broadband connections. One of them is also used for cable connections. The other one is generic errors. We have UPnP bugs, DLNA bugs, and etc. So they can be exploited. Who exploits a modem? People do. One of my friends, Leon Yang, was working on MIPS exploitation, and he had presentations in DEF CON, hardware hacking and IoT villages, also hacking the bugs and etc. He is really so passionate to work on it. Also, damn vulnerable router software, router firmware is also available. So you can download that firmware. You can work on your own exploits. Okay, forget about it. What is the public information for that? The first one is dumping credentials and etc. The second one is, as you can see, the console and exploits. They are the modems we use. The funniest one is the last one. The funniest one is an admin leak. There is a modem offered by a service provider. If you get the password HTML has the administrative password in plain text. So you don't need to log on. You can visit the password HTML, grab the password, and use it. That's it. So it is really dangerous. But I focus on the hardware hacking stuff. what we can do to those devices? UART is the interface to get console access or debug access to those devices. So UART has TX, RX, ground, and voltage pins. So we are talking about 4 pins. But sometimes vendors put another one for security, but sometimes they remove voltage. So basically transmit and receive are the important ones because we will send some data and we will get some data. JTAG is another one. It's a debug standard, basically. Manufacturers provide and manufacture thousands of devices, and they need to test them. That's why they use a standard for that. And JTAG is the answer. But the thing is, the JTAG standard is slightly flexible, so it depends on the vendors. Yes, pin pads and connections, they are a bit standard, but vendor may add additional pin pad, additional security on it. SPI is another way to reach the flash or system on chips. So basically, we can communicate with them directly using those interfaces. So why and how we use it? The why is those devices. Because we love those devices, so we need targets. I love Bus Pirate or Bus Blaster or Jet Regulator, Shikra, Hydra Bus. They are really good devices. They are all here. And I need some targets. That's why I opened the boxes. That's why we are playing with them. No one hired me to focus on them. I had former engagements focusing on broadband connections and some IPTV systems, and another one was femtocell modems and etc. But my focus is hardware hacking. But during an engagement, I need to do this within a limited period. It is not always possible. Even dumping a firmware will take ages. Sometimes you need to brute force the JTAG interface to find the right instruction list. How many of you understand me about taking time? Yes. It will take time. So vendors do not pay attention, but devices do. So those are my tools to connect system-on-chip clips or Hydra Bus or JTAG regulators. So they are helpers. Some of the tasks are already automated, and they are also well known. The other one is a modem. This is a modem offered by a service provider, and if you look closer, you will see 2 UART connections there, and they are already prepared, so we need to plug our cables only. Another one is here, and this is coming from another service provider in Australia. But this one had no pin, actually. I just soldered 4 of them. So sometimes they have pin pads, sometimes they have pins. So we can use them. So I plugged my cables, and I connected through my hardware hacking tools. This one is a 4G wireless modem of a service provider. So when you unplug the battery, seal the board, you will see the interfaces. I mean, when I say seal the board, it's just a sticker. Unstick it, and you will see this. And JTAG interface is already written there. So what I did is soldering them and putting on JTAG regulator and identifying the JTAG interface, finding an ID, and starting with Bus Blaster to play with it. And the other one is here. We focused on the UART interfaces, but we are missing something else. This is another system on chip. I do not know what it is. What can I do is basically putting a clamp on it, a clip. So basically, it will connect all the ports. Actually, not the ports, they are legs. It's an electronic circuit, basically. And I connected all of them to my logic analyzer to understand, is there any firmware inside? Or is it a power controller? Is it an Ethernet controller? What is it? So I worked on it again. So if I get a UART connection, the 4 pins in the first place, basically, I will get all those 4 connections, which means I will have an access to bootloader or console access. The other one is real-time debugging. This is also good. If I plug this, and if I will operate some tasks against the modem will provide some debugging output to me. Sometimes it gives me root access without any password. Most of the time, it ends like that. And basically, 4 pins need to be identified. Sometimes they are pretty open, like in this example, 3.3 voltage, and ground, out, in, and etc. But we need to find the ground first. Ground is the easiest one, so you can use a multimeter for that. You need to find the voltage pin, Again, it is also easier. You can use another multimeter to measure that. When you find the correct voltage, you can set the target voltage using your tool and try to communicate. Basically, you will try to send the data and try to receive a data. So transmit and receive must be reversed in your board. So you need to use your transmit pin to their receive pin. So basically, it must be like that. If you do this wrong, just switch it, so it will work. Anyway, the problem is speed, baud rates. So basically, you can brute force it, but lucky punch is 115/200. If you do not have any lucky punch, you can use JTagulator to brute force it. Sometimes it is also encrypted. Some vendors use an embedded digital certificate to encrypt this data, and they wait a kind of authentication. So basically, all the data, including the logon console, encrypted. But I had only one example like that. The rest are easier. You can use JTagulator to brute force it. So this is a video, and this needs to be playing. Yes. Putty is the tool I try to use to JTagulator. So JTagulator will have pins to connect. I plug those cables to here, and it will try to brute force them. I need to plug the ground to ground and the rest to other pins. For the UART, you don't need to use, but it's a basic demo, so you can understand how it works. So starting channel 0, ending channel is 2, because I had 3 cables, so it will identify what is it and how. JTagulator is a brute force tool. It is not a kind of console access tool, or it's not a kind of JTAG debugger, so it will only brute force it. As we can see, we have some data, and if this data is not meaningful, it is okay. If it is meaningful, you can try that baud rate to communicate. In this example, we will use first and second pins for transmit and receive, and we will set a baud rate, and we will get UART pass-through, and as we can see, it is there. But again, JTagulator is a not good tool to communicate through UART interface. It will lose some characters. That's why we need to use a tool dedicated. I suggest Bus Pirate or Hydra Bus. Actually, Hydra Bus is my racing favorite. It has multiple connections, and it has also NFC board, and it is programmable using Python, and it has its own firmware. It may react just like our other tools. Anyway, if we get UART access, basically we will get debugging, logging, intercepting the boot sequence. So basically we can intercept the CFE bootloader, and we will get console access, or we can do more. We'll see. This example is on Netgear. Netgear is another modem offered by another service provider. So this is our other demo. Basically, when we find the modem interface based on UART, so basically UART is a console access, and we will plug our cable, and we will try to get login and password. So we can try brute force if it is based on login access, but basically we can restart the modem, so we can get the debug input as well. We may have some additional ways to find the root password. It is also possible, and I will refer it during SPI. When we restart the modem, we will see what is going on, how it boots, which services are there, and which service provider is there, and how it is getting configured, and how it is getting managed. In some of my examples were TR69 and DOCSIS, but this depends on the device. As we can see, we see the boot access, that's all. Actually, this is a basic boot log of a sort of Linux, Unix version. Anyway, if we get CFE access, we will have a kind of bootloader access, which means we may have some additional options, reflashing the modem, changing it with a customized firmware, or we can overwrite the information, or we can harvest the credentials, or we can extract the data through the CFE interface. It also supports sometimes dumping the firmware using a TFTP server. So you can set a TFTP server, and you can ask it to upload all the firmware to that TFTP server, or vice versa. You can put a customized firmware to your TFTP to try to deploy it. So another example is based on Sagem.com. This is also another modem offered by a service provider. Sorry. Would you play the video? There is no event for that one. Please, thank you. Yes. When we boot the device, we will see the CFE interface. When we hit the button, we will see the CFE interactive interface. So we may have options. CFE seems like a standard, but it is not. Vendors may add some additional options. In this case, changing the board or reflashing it or erasing a non-div flash. They are all other options. So we may have some additional options. UART is the first way, yes, but we may have JTAG standards. It's a debugging standard, so basically everything depends on the vendor. Vendor may add new pins, or vendor may add additional layers. So the daisy chain is defined as a standard. So input, output, clock, and mode select, they are there. But vendor may have some additional devices connected to actually on the board. So the modem board or the active device may have multiple CPUs, multiple system on chips, and multiple active devices. So we can use this daisy chain to send data and get output from every one of them. And basically, we need to identify those JTAG pins. When we give a closer look, we will see them. Sometimes they are labeled, but most of the time they are not. If we are working on them, we may have some difficulties. In my example, I need to keep the battery all the time because the device must be fed with the power source, and it was battery-based device. So I needed to catch it like that. So in my JTagulator demo, basically I will use another brute force for JTAG. It is another feature of JTagulator, and it can discover the JTAG interfaces. If we use ID code scan will identify the pins, but it will not easily find the input pin. So basically, we may need to put some additional scans. So what we try to do is identifying all the pins. If we identify the pins, we may identify the devices connected to that chain, daisy chain. So basically, we may find 3 or 4 or maybe 5 active devices on that modem or consumer device. As we can see, JTagulator is brute forcing it. So our data will be appearing now. Also, you don't need to use JTagulator for that. You may use Bus Pirate or Hydra Bus for this feature as well. Hydra Bus may also perform automated brute force attacks against this. As we can see, TDI, TDO, TCK, and TMS, and T-Reset, of course, they are appeared. This is a 4G modem offered by a service provider now. So what can we do with that? Bypass scan listed the pins. So we can use those pins to send test communication. How many devices are connected? What is the vendor ID? Test the daisy chain. Works or not? Send an input and wait for the output. They match it or not? Because the chain may have issues. We may have issues. Maybe pins are wrong. So I operated some test operations. In this list, we see the components connected. So manufacturer IDs are there. We will use them. So basically, when we send a test request, we will see the daisy chain works. But those vendor IDs are also important. Starting from that moment, we will use bus cluster and a software, let's say OpenOCD or URJTAG, to brute force that JTAG commands, because they are test commands, right? So we need to use them. If we use them, we can easily dump a device memory or we can dump a firmware. We don't know. The other way is SPI. SPI is direct communication with the flash or system on chips. They may have multiple legs, sometimes 8, sometimes 4, sometimes 16. Sometimes we have clamps. Anyway, we can use them to dump. The question is, why we do this? Service providers have those devices, broadband, IPTV, and satellite. And devices are connected to their infrastructure, and they are under management of TR69 or DOCSIS or in the consumer premises. And relying on vendor security is not sufficient, and many service providers do this, rely on the vendors. So what we can do is basically altering the devices. Yes, but let's make it a real-life attack, right? First of all, many vendors are in that pool. So device provisioning is important, and they have software configuration management as well. So they need to put some operations on it. Moreover, call center connections, they are also there because the subscribers need some support for those devices. Generic information in the wild can be used for that. OpenWRT and DDWRT are open source communities, and they list all the JTAG instructions of broadband modems or your video on demand devices, STPs and IPTV boxes. So basically you can use them, or you can use bypassing controls. They are all available everywhere. And bring your own device is another challenge with that. And in this case, we may have a modem. Modem will be in a provisioning pool. One of them may be provisioned, the second one may not, and third one may different. Provision is based on a protocol. TR69 is one of them. If we see TR69, we will see auto-configuration server, some SIP services supporting the UC backend, and some radius connections. But some modems will not be provisioned. Maybe they are not registered, but the other ones will be bring your own device. So we can use them to attack the infrastructure again. If we alter a device in a way, putting our device or the other devices, we can attack the devices in the same pool, or we can attack the services not available in the wild, but available in the service provider networks. Moreover, if we alter the devices or services, we may have access to the call center, because call center needs TR69 management interface. If you send a fake modem ID or some data, you can manipulate the TR69 software, and TR69 software is also used by service provider call center agents, and they may have some cross-site scripting issues or maybe code execution issues. Sometimes they have. Another one is set-top boxes. Set-top boxes basically feeded by cloud. There are streaming services and DRM protected services and web services to manage licenses, keys, and billing. So if we alter DVB or IPTV boxes, basically we may have some goodies such as keys, access, credentials, licenses. And service provider also need to provide some background for them. These backend services are basically, again, management services, and they are again based on TR69. If you alter a device, you can easily extract the video encryption keys or credentials, or you can easily target the service provider itself. Moreover, you are using a phone, you are using a PSTN phone, right? No, you are not. You are plugging it to a smart device, and that smart device is connected to the service provider in the background. And that backend services have TR69 management again, and they have voice over IP services again. And moreover, you may have some phones in your building, but that building access must be provided by another device because it is another media gateway. It basically provides the service provider infrastructure to your building. If you alter that device, you may have unified communications access, or maybe much more dangerous access to the service provider network. If you alter the smart modem, you may harvest the voice over IP credentials, which may be a problem because service providers assume that you cannot alter the modem. So basically, their voice over IP infrastructure is secure. I'm saying this because I have too many unified communications projects, and I'm performing this day by day, basically. Anyway, let's talk about the other one, femtocell devices. They are also devices, and they are a replacement of a base station. If there is no base station, there is no GSM signal, they are alternatives. So you can get one from a service provider. Fortunately, they terminated this service about March. So we had 2 service providers in Australia, and they just terminated those services. I bought 2 femto devices through Gum3, and one for each service provider. I just altered them, and they are there. And one of my former engagements had similar configuration as well. And they use similar configuration because the vendor is almost same. So what we do is analyzing them, yes, but what if we get more information? They are connected to the backend services using IPsec VPN. And if we change them again, we will have TR69 as an attack surface. And we can also attack to the background. So just a sec. We are saying TR69 all the time. Basically, all those devices connected to the auto-configuration servers running in the service provider network. So service provider network also puts some additional data. So our devices, modem devices, have a service running on themselves, and service provider has another one. So they communicate when they need service. So this is a kind of two-way communications. If you alter a modem, you can be the man in the middle. You can modify the original content. So what you can do is basically debugging the protocol, gathering information, extracting or harvesting everything, or maybe manipulating them to attack server, service network, or clients connected. Moreover, we can dump the credentials, firmware, everything. So devices may be dumped. And some of them, DRM keys, IRDATO keys, credentials, they may be really relevant. And dump device firmware is another way to work on further exploit development features. Driving a consumer device is another goodie, because we can also manipulate the billing features, or we can bypass some security controls. We can provide a fake base station. So office devices, they are also under attack, as I said. Some of them are here. As we can see, they are backdoored. Some of them are open source. Some of them expensive to replicate the attack, because backdooring using implant, it is not easy. Red teaming engagements need them, because we are evolving, because they are now a part of our engagement. And human factor pen testing, they should also evolve. We need to change the devices, and we need to send them like that, compromising a webcam, or sniffing the wireless keyboard, or force-pairing a mouse or modem. This is also possible. And backdooring a device is a goodie, but it is a well-known thing. What if we use the advanced attacks? There are a few. The first one is K-Sweeper. You can easily sniff wireless Microsoft keyboards, or you can use mouse jack to force pair your keyboard or mouse with another computer's receiver. So basically, you can easily force pair things to get additional access. So they are there. But hardware implants are expensive. If you want to work on it, you may need a time and a period. Let's say you need engineering. Sometimes we don't. That's why we need to put some immature samples. And we need to find power source. We need to put it everywhere. And we need to put them to the real life examples. And 2 years ago, in my Black Hat USA talk, I provided a sample Cisco IP phone modification. The phone is still with me, and I'm still working on it for some other cases as well. Again, it is my personal equipment. And in this case, this is a second board sticked on the original board. When we reverse it, we will see some pins. And when we solder those pins, we can easily patch a cable. And that cable can also provide connectivity to the voice VLAN. If we put our Raspberry Pi inside, if we feed it using the power source, we can put a Cisco IP phone with Raspberry Pi persistent connections. And it is pretty good, because it may also feed using power over Ethernet. And of course, how should we fix this? How should we solve the problem? Enforcing vendors to disable things such as physical interfaces, or using encryption. They should start using encryption, and we should talk about strong encryption later. They have no encryption almost. And follow a security standard. And thanks to Andrew. Andrew highlighted another good topic yesterday about iOS security ratings, and maybe we should follow that path for that. And network isolation for subscribers, it is also important, because this may be a provisioning network, or maybe a kind of restricted management network. And tailored research is another answer for the service providers, because they need purple team. They need some response capabilities and red teaming capabilities to understand the infrastructure, identifying the existing threats and anomalies, and after that, starting testing of these features, such as devices or protocols. So they are all connected. Moreover, as a security tester, we need to evolve. We need to put all devices in scope now. They are not out of scope anymore. And we need to think different. We need to combine the mobile features and the devices, and everything is a target now. So we need to work on some additional cases. For example, service provider networks. They need some special attention. We should not operate only external network testing for them. And of course, tailored research is an answer for both sides, and I suggest this to focus on all components, focus on every devices, and focus on exploitable issues, not to, let's say, dangerous RC4 implementations. Yes, they are security issues, but there are real-life attacks, and they focus on exploitation, and there are really bad vulnerabilities on those devices, and they are exploitable, and they may lead to full compromise of service provider network. Combining various skills and disciplines, it is also required because they are embedded devices. They may be integrated to a mobile background or infrastructure objects. So it closes the gap between offense and defense. So these are my references. So if you want to pay more attention, you can visit them, or you can find me everywhere. So I have almost all those devices. And if you have some technical questions, I can also pay more attention during lunchtime as well. And if you have questions, I'm able to take them as well. Thank you for listening to me.
We've got a couple of quick questions. One was already pertaining to the TR69 protocol, so I might skip that just before we break for lunch. But yeah, what modem or router brands would you recommend to be more secure than others, excluding pfSense and... or maybe also what router brands do you recommend that are more OpenWRT, DDWRT kind of compatible?
Okay. In my point of view, some vendors have solutions and they ship their products with different firmwares. Sometimes they provide a secure firmware as well, but they do not contact other service providers to fix it. So basically, it's a kind of one-way direction. They evolve, but they do not fix the older products. So if a service provider asks an older product line, they just ship all of them with old firmware. So I think they can all make it secure. There's no difference between the vendors in this stage. Actually, there is no major difference between the service providers. But they need to pay more attention to the product itself. That is the major difference, I think. The embedded software is the second step.
We'll break for lunch, and if everyone could give a round of applause for Fatih.
Thank you. And again, I will be available here, so I will be outside, so please find me, and we can discuss about things, okay?